Very good afternoon, fellow Foundrymen. It gives me immense pleasure in interacting with you all for the 23rd technical webinar for the year 2022-23, which is jointly conducted by the Institute of Indian Foundrymen, Chennai chapter and Andhra chapter online through Microsoft Teams platform. To get things started, we now request Mr. R.A. Prasad, Chairman, Andhra chapter, to welcome the gathering, please.
Thank you.
Yes, sir.
You are able to hear, sir?
Yes, sir. I can hear you, sir.
Okay. Good afternoon to all the members. First of all, on behalf of Andhra chapter, I express my sincere gratitude to Chennai chapter for organizing the program jointly in association with Andhra chapter. Mr. Sittuvel, Mr. Ramanan, Vignesh and Mr. Raman and Mr. Dayalan, especially as per our discussions held on 28th October at Vijayawada, the program is being planned today and is the program as known to you all. It is a best operating practices for energy conservation and case studies by Mr. Dr.R.Sivakumar, a renowned energy certified engineer. And we'll go ahead with the presentation, and I welcome all the members to enjoy the program, utilize the presentation, which is points or tips given by Dr. Sivakumar to implement in our day-to-day operations in Foundry. Thank you and welcome once again all the members.
Thank you, Prasad, sir. Now to introduce our speaker for the day, may I now request Mr. Rajmohan Madiyaragan, Council Member, IIF Chennai Chapter, to introduce our speaker for the day.
Good afternoon, everyone. It's my immense pleasure to introduce Dr. R. Sivakumar to the audience here. Dr. R. Sivakumar is a certified energy manager by Bureau of Energy Efficiency. He is working as a cluster leader at Coimbatore for GEF-UNIDO-BEE project on promoting energy efficiency and renewable energy in the selected MSME clusters in India from July 2014. He has 25 years of field experience in plant maintenance, projects, energy conservation, energy efficiency, training and commissioning. He has written several articles on energy conservation and energy efficiency and handled a lot of national workshops and national conferences under the same subject. He has educated and trained engineering students and faculties in the field of energy management and energy conservation. He has served various positions in the industries like DuPont India, Precol Limited, MMG India, and Coimbatore Institute of Engineering and Technology. He holds a membership with Institution of Engineers, Kolkata, and he's a life member in Society of Energy Engineers and Managers, and he holds a membership with ISTE. We welcome you, sir. Over to you, sir. Thank you.
Sivakumar, sir, you can start the presentation. Thank you.
Yes, sir. Thank you, sir. Thank you, sir. So, good afternoon, everyone. So, first of all, I thank IIF Southern Region, Mr. Muthukumar, Chairman, Southern Region, for giving me this opportunity to train about the best operating practices for energy conservation and case studies. And also, I thank IIF Chennai chapter and also Andhra chapter. I will thank Mr. R. Saktivel Tirunavukarasu, Chairman, Chennai chapter, and Mr. R.A. Prasad, Chairman, Andhra chapter, and Vignesh Ramanan and V.M. Kishore Kumar, Honorary Secretary of Chennai chapter. So I am Dr. R. Sivakumar, working as a cluster leader under the project called Promoting Energy Efficiency and Renewable Energy in Selected MSME. This project was started in the year 2014. So we are working under different manufacturing sector, under 5 manufacturing sector called foundry, brass, hand tools, and dairy clusters. So in India, almost 6,000 foundries are there, various clusters are there. In our project, we formed in foundry cluster, 3 clusters are formed. One is Coimbatore, second is Belgaum, third is Indore. This particular project is basically it is funded by Global Environment Facility. It's a part of World Bank, and also it is implemented by the another international organization called UNIDO, United Nations Industrial Development Organization, and they are working with together and India, like BEE, Bureau of Energy Efficiency is the technical agency of this project. So our cluster partner in Co-India, Coimbatore is, there is an association called Co-India, Coimbatore Industrial Infrastructure Association. Okay, so we are working in the foundry sector in more than 8 years under this project. Almost in the first phase, we covered nearly 100 foundry units. In the phase 2, we are covered another 130 foundry units. So that in Coimbatore, almost 250 units are foundry units are benefited directly, and 400 units are benefited indirectly. So far, we are conducted a lot of energy clinics and energy management programs, in-house training program in NPC, various training program was given. So far, we are trained around 1,500 foundrymen in Coimbatore cluster, and we achieved nearly 13.1 million kilowatt hour energy saving in our cluster. In the monetary saving means it comes around nearly 28 crores rupees per annum, and the investment cost is also around 30 to 31 crores by the foundry units. These are the achievements through our project, and also we are developing various guidebooks for the foundry units, and it was discussed with the various units in the form of posters, and the best operating practices also shared with. We are taking one best case study with one foundry. The same thing can be trained with the other foundries also. So these are the various achievements done through the project so far. So today the session is the best operating practices for energy conservation in foundry units with the case studies. Okay. Sir, I am audible, sir. I am go ahead. Hello.
Sir, yes, sir. Please go ahead, sir.
Yeah, okay. So next slide, sir. Dinesh. Yeah, today's agenda is first one is why we need to conserve the energy. What is the need of conserve the energy? Why we should go for the energy efficiency technology? What is the basics of energy conservation? Second one is best operating practices in melting, especially for foundry. Melting is the major area of energy consumption area, and some of the case studies implemented in our project also we have to discuss. And the best operating practices in motors with the case studies, as well as pumps and blowers, and best operating practices in air compressor with the case studies. Finally, what is the necessity of energy audit in the industries? This is the agenda of today's program. Next. So energy conservation. First. So in this picture, you can see there is a bell curve is there. So after this industrial revolution, in the year 2000 onwards, the energy consumption rate is very high in all over globally, worldwide. Even in India also, very much energy consumption is in the faster rate in the after 2000 only. You know one thing, in the year 2003 in India, the installed power capacity is only around 140,000 megawatt is the installed capacity. Now in 2022, almost it nearer to the 3.96 lakhs kilowatt megawatt was installed. Lakhs megawatts was the installed capacity. So within this 20 years period, the energy sector was grown in 3 times. That is compared with the 2002, the installed capacity is less than 1.4 lakhs unit, 1.4 lakh megawatts only. Now it is crossing nearly 4 lakhs megawatts. So in India is also growing very well in the energy sector also. So always they are speaking with the country GDP, gross domestic product. So if the country is growing, means there is one figure is called GDP rating is there. So if the country is growing, means in the energy sector is also parallelly it's grown. Then only the country is development. So the importance of energy conservation is because we are taking the energy, mostly electricity and oil, gas. These are all came from the fossil fuels. So what is fossil fuels? Because it is the depleted with the time period. So over a period, the fuel was depleted with the time. So in the statistics says 2002, the coal availability in the global reserve is for only 200 years during that year of 2002. Now 2022, the statistics data says it was available for only 135 years. So within 20 years, we are consuming nearly 65 years coal. Similarly for others also, oil, gas. So everywhere the fossil fuels are depleting day by day. So for the next generation, how the fossil fuel is available? Because most of the energy was generated from the fossil fuel. So far we are 60% we are so far consumed, and 75% of the energy comes from non-renewable energy sources. Next one. Sir, if you have any doubt, you can interact, or otherwise at the end of the program we can discuss, sir. Okay, sir? Can I go ahead?
Yes, sir. Please, sir.
Hello?
Go ahead, sir.
Yeah. So basically, energy is divided into some kind of different type. One is fossil fuel based and renewable based. Basically, renewable is get it from the natural, and it is inexhaustible. Always we can take it from the renewable, like solar, wind, hydroelectricity, biomass. This energy comes under renewable energy sector, and the non-renewable is other than renewable is covered under non-renewable, mainly fossil fuels like coal, oil, and gas. This data say loss of 1 drop of oil every second, it can cost over 2,000 liters per year. So even in our company, there are lot of diesel, HSD, and furnace oils they are used in the industry area. In the most of the flanges, it was lightly leaked. Even 1 drop of oil in every second, it causes nearly 2,000 liters per year. It is lost. So it is very, very. We have to conscious. Next one. Dinesh, next. So this is the data shown. As per the Indian statistics, the sector-wise energy consumption is almost 49%, nearly 50% of the total energy was consumed by industry. Next one is the major sector is transport 22%, residential 10%, agriculture 5%, remaining is 14%. Next one. So global energy resource, already I discussed, the global coal energy reserve is 861 billion tons, whereas the reserve to production ratio, it's 120 years at the present consumption rate. What is mean by reserve to production ratio means at the end of the year, during this particular year, financial year, how much coal we are consuming. So the same coal can be repeated for the next subsequent years, how much years it is available reserve. That is called reserve to production ratio. So earlier I told, this data deficit, the data of 2022 data, whereas in the year 2003, the statistics says the reserve to production ratio is 200 years. So we are lost nearly 80 years of the coal was consumed within 20 years period. So it is very, very alarming, this one. The next one is oil reserve is also almost 1,669 billion barrels, and the reserve to production ratio is 42 years. Similarly, for the gas is 187.3 trillion cubic meter, and the reserve to production ratio is 60 years. This particular gas reserve is only increasing because many places they identified the new reserves available in the gas. So that's why compared with the 2002 and 2022, in the 2002 the data shown around 45 years. Now 2022 it will be increased because of the new places identified and the mines are identified for the gas reserves. Next. Next slide. Dinesh. Dinesh. Sir, I am audible. Yeah, global warming and climatic change. Due to this fossil fuel depletion and more carbon dioxide emission, these are all the ultimate thing happened by global warming and the climatic change impact. Last week only there is a conference of party COP26 meeting was handled by United Nations in the Egypt. So almost all the nations leaders are attended the meeting, and they are given some commitment, how to reduce the carbon dioxide emission, how to reduce the energy consumption. All those things are discussed in the COP, and next COP27 is also happen. Every year they are discussing. So mainly they discuss about the climate change and the global warming. Due to this fossil fuel consumption rate, because of the global warming is happen, automatically every year there is some 1 to 1.5 degree temperature was rise. It was indicated by the United Nations. At least every 10 years once, nearly 2 degree was raised by the global overall temperature. So it will lead rising the sea levels, and the snow and ice melting was happened, and also it altered the rainfall pattern, especially in India. We are facing last 15 years more rainfalls during the period, and flooding was happened. So before 15 years before, we are not noticed any this kind of floods are there. Now we are also facing lot of over rainfall was happen because of due to this global warming and the climatic change pattern changed. And also we are not getting the proper monsoon rain. Whenever we are having some any low pressure depression in the Bay of Bengal or this one Arabian Sea, we are getting more rainfall. So this rainfall is happen. The main reason is because of this global warming and the climatic change. So the next one is the extreme weather events. So we are facing more flood as well as more heat in the summer and severe heat waves and the loss of biodiversity and increased diseases because of this food shortages are there. These are all the consequences of this global warming and climatic change pattern. Due to this one of the main reason is this fossil fuel consumption and depletion. Next one. So as an India, the energy outlook, we are outsourcing all the energy. Almost 85% of the energy consumption by India was outsourced by the neighboring countries, especially oil. Oil resource, we have only 9 to 10% only. Remaining 85 to 90% we are depending on the Middle East country, Gulf countries. And with the 15% of the global population is almost 8 billion, nearly 1.4 to 1.5 billion population in India, and 0.5% of the petroleum reserves in the world, and 10% of the world coal reserves, 8 to 10% GDP growth rate. So it is a very, very toughest target for India to achieve the GDP rating and the country level development and all those things. And this is the main outlook of the India's perception. Next one. So this says this picture represents one of the thermal power plant electricity generated. So every unit of electricity used to generate 0.82 kgs of CO2 at the power station, and 1 kg of coal produce 2.2 kilowatt hour only. Normally, the coal calorific value is roughly somewhere in 4,500 to 6,400 kilocalories, and it depends on the coal purity and carbon content inside the coal. Basically, Indian coal quality is very good compared with the African and the Indonesian coals. So in the thermal power station, they used to produce the electricity through the coal as an input fuel. So 1 kg of coal we are burning, we are getting only 2.2 kilowatt hour. So 1 unit's generation is 0.478 kg of coal is required. So this is the scenario in this one, and also during this generation, 0.8 kg of CO2 was emitted from the power station for generating every unit of electricity. So that the CO2 emission is very, very high. That's why India was committed in the year 2030, almost 50% of the installed power capacity to be get it from the renewable energy. By the year 2070, India committed 100% it is carbon neutral. That means all the 100% of the energy requirement through the renewable energy. Even in automobile sector also nowadays the electric vehicle is very popular, and over a period within 5 years period almost 50% of the vehicle is in the road by electric vehicle only. These are all the committed towards to reduce the energy as well as to protect the nation and as well as global. So the 0.82 kg of CO2 was emitted for every 1 kilowatt of electricity is generated. Next one. So these are all the various kilocalories equivalent for the various energy. Electricity, almost predominantly we are using majority of the energy from electricity only. If you are consuming 1 kilowatt of electricity means 1 unit is equivalent to 860 kilocalories. Same way coke, especially in cupola foundry units, they are using the coke as a fuel. Dominant fuel. So the coke calorific value is also somewhere between 4,200 to 6,500 kilocalories, depends on the quality of the coke. And the diesel, where diesel is classified as a high-speed diesel, low diesel oil, and furnace oil. So this diesel and furnace oil calorific value is somewhere around 9,783 for diesel, and the furnace oil is 9,383. For the LPG, the calorific value is 12,500 kilocalories per kg. Next one. So this is the Indian scenario. As on date June 2022, The installed power capacity is 4,03,760 megawatt. Under this, the thermal station accounts for 58.5% of the total installed capacity. Nearly 2,36,065 megawatt is came from the thermal based, and the renewable energy is almost 39.7, that is 1,59,949. Nuclear is 6,780 megawatt, 1.7% is the contribution. Next. So power development in India. So from the independence 1947 onwards, see, you know one thing, the total installed power capacity during the independence period 1947, we are having only 1,362 megawatt only. Out of this 1,362, 854 from the thermal and the hydro is 508. Whereas in the 2002, from 47, 50, 61, gradually the power sector is increased. After this 2002 to 2022, there are a lot of improvement is there because of the industrial activities and globalization. So from the 2002, the installed capacity is 1,05,046. In the year 2003, the figure says almost 1,27,000 megawatt or something. In the year 2022, it comes around 4,03,760 megawatt is the installed capacity. These are the power sector development in India. Next one. So energy management. So energy management is the process of monitoring, controlling, and conserving energy in a building, factory, or organization. How the energy was managed and well utilized. This is called energy management. Under this energy management, there are two things. One is energy conservation and one is energy efficiency. Both the area, energy conservation as well as energy efficiency, there is some energy savings. But the different thing is in the energy conservation, the behavior that results in the use of less energy, and in energy efficiency using technology, energy efficient technology that requires less energy to perform the same function. So the simple example, the picture is also represent turning the lights off when leaving the room, or otherwise you have a conference room, you have a meeting for 1 hour, 10 lights are used for the meeting. So instead of using 10 lights, somewhere 5 lights can be switched off. So by using switch off the 5 lights, we are saving some energy. So that is called energy conservation. In this energy conservation, our comfort level was we are sacrificed. So we are instead of 10 lights, we are using only 5 lights. Whereas in energy efficiency, without switching off all the lights, the existing fluorescent tube lights can be replaced with the energy efficient LED lamps, so that same lux level and lighting level we are getting, our comfort level is also maintaining, but the energy saving is also achieved nearly 50%, because fluorescent lamp to LED lamp conversion means 40 watts tube light can be replaced with 20 watts LED lamp, so that we are saving 50% of energy. In both the activities, we are saving energy. The difference is energy conservation behavior that results in the use of energy, because our comfort level can be minimized, so that we are saving some energy. Whereas in energy efficiency, using the latest technology, energy efficient technology, and the same function and performance to be achieved with the use of less energy. Next one. So this is the example. The conventional incandescent lamp, 60 watts, it's using 60 watts means the approximate emission CO2 carbon dioxide emission is nearly 65 gram per hour. Whereas this can be replaced with the energy efficient compact fluorescent lamp. Now the CFL lamp is also old technology. Now they are replaced with everything was replaced with the LED lamp. So the incandescent lamp 60 watts can be replaced with the 8 watts LED lamp, equivalent lamp, so that the CO2 emission reduction is almost 16 grams per hour. So from 65 to 16 grams, nearly 75% of the CO2 emission was reduced because of converting from the incandescent lamp to compact fluorescent lamp. Even we are changing LED, the 16 grams become 8 gram per hour, so that the energy efficient equipments uses less energy for same output, and it reduces the CO2 emissions. This is the meaning of energy efficiency technology. Next one. So energy efficiency benefits industry, nation, and global. If the energy efficiency program was effectively implemented by the unit, these are all the benefits by the individual industry: reduce the energy bills, increase the competitiveness, increase the productivity, and improved quality, and increase the profits. These are all the industry, and nationwide reduce the energy imports, so the country can be reduce the energy imports called oil and gas and even other resources also. This avoided costs can be used for poverty reduction. For example, 1 megawatt power generation plant, for constructing 1 megawatt, the investment cost is roughly, it comes around more than 10 crore. So that doing energy conservation program, we are saving to the nation to reduce the power plant capacity additional enhancement. So these costs can be used for the poverty reduction and the conservation of limited resources and improve the energy security. These are the nation's benefit due to this energy efficiency program. And globally, the energy efficiency benefit is reduce the greenhouse gas emissions and other emissions, and also maintainable environment. These are the benefits through energy efficiency by industry, nation, and as well as global. These are the chain reaction. If one industry was doing energy efficiency, it can be directly benefited by the nation as well as the global. Next one. So far, we are completing the first chapter. What is the energy scenario? What is why we need to conserve the energy conservation. The next topic is the best operating practices in melting. Can I go ahead, sir? If any doubt. Hello? Hello?
You can.
Sir, doubts at the end, sir. End of the presentation.
Okay. So the next one is Foundry, best operating practices in melting. So this general diagram is already everyone knows, all the Foundrymen knows about this Pareto analysis chart. So in the foundry, basically in induction foundry, 70% of the energy was used by the melting section. Remaining 30% of the energy was utilized by the auxiliary loads. Basically, we are call it as auxiliary loads like compressor, molding and core preparation, sand preparation, lighting, and other pumps and cooling systems. These are all the various consumption. So the 70% of the total energy consumption by the unit was gone through the melting section only. So we are having to improve the melting energy performance, even some 1% to 2%, it will impact more in the energy saving bills, in the energy bills also, compared to the auxiliary loads. So that the melting area is a very, very key area in any foundry. So that the melting energy consumption, if you are reducing, you can save a lot of energy. Next one. So energy consumption in melting, a modern induction furnaces can melt a ton of iron to raise the temperature of liquid metal up to 1450 degree using less than 600 kilowatt of electricity. Typically, this specific energy consumption, normally it is called as a specific energy consumption. So this energy consumption is varied between 550 to 800, even 500 is also only 1 or 2 foundries only achieved. So normally the range of specific energy consumption in the medium scale foundry units somewhere around 650 to 700 units. So basically it is varied even in Coimbatore cluster also. Foundry to foundry, the specific energy consumption is varied because of lot of reasons like material scrap and usage pattern. They are not using the furnace continuously due to this various reason. So depending on the type and grade of casting, the specific energy consumption is also varied up to 800 kilowatt. So the benchmarking says the theoretical energy needed for to rise the temperature of 1450 degree, the theoretical energy requirement says only 392 units. So that means 392, 400 units only. But practically we are ended up with more than 650 or 600 and above only. So there are possibility of saving in the melting alone, minimum some 50 to 60 units we can save by using best practices and the best technology and the best operating practices itself. So some of the best practices for induction furnaces, operating efficiency of an induction furnace involves preparation with the right mix of raw material, charging of the stock, melting, and pouring of mold. These are the some of the practices we can see one by one. Next. So best operating practices in melting. First one is some 10 best operating practices is there. First one is furnace lining preparation. So furnace lining plays an important role in overall performance of an induction furnace. So the installed lining as prescribed by the OEM furnace manufacturer to get the optimum result for energy consumption, and selection of appropriate lining material with the proper thickness, and the sintering plays also major role in the energy saving. So thick lining reduces furnace crucible volume and hence the molten metal output resulting high specific energy consumption. The next one is thin lining. Though it improves the power density, promotes heat losses from the sidewall lining material with high thermal conductivity. It causes more heat loss, and improper lining is causes the premature failure. So it is very important. So thinner lining is also dangerous, and thick lining is also leads more energy consumption. We have to optimize the lining thickness. Second one. Next. So preparation of raw material. So energy consumption pattern for induction furnaces depends significantly on the nature and the quality of scrap, raw material charged into the furnace. So first of all, we have to wait and arrange the raw material on the melt floor nearer to the furnace before starting the melting. And the charge must be free from sand, dirt, and oil grease. Rusty scrap not only takes more time to melt, but also contains less metal for charging. It creates a lot of slag formation inside the crucible. So the charge material should be very free from sand, dirt, and oil, dirt parts. And the foundry return, that is runner and risers, must be turned short blasted to remove the sand. So that typically runner and riser consist of 2 to 5% of the sand by weight. So it should be removed by using short blast machine. Keep the exact weight of alloys ready before charging, as alloys are very expensive. So proper handling will not only reduce wastage, but also reduce the time lost in the alloying, so that your melt timing period is also reduced. The maximum size of single piece of metal scrap should not be more than 1/3 of the diameter of the furnace crucible. Many of the foundries are using the without proper sizing of the scrap or material, raw material poured into the crucible. The size of the material is oversized, so that your gap will be more, so that the generation of the electricity due to this induction, no, that is also wasted due to this less packing. Hello. So the maximum size of the single piece should be less than 1/3 of the diameter of the furnace crucible based on the capacity. 500 kg crucible, there is one dimension, one tonnage and 750 kg crucible. The dimension is varied based on the diameter of the crucible. The size of the raw material to be sized 1/3 accordingly. So minimum less than 1/3. There should be no or less sharp edges, particularly in case of heavy and bulky scrap. It leads to damage the refractories, so that the sharp edges can be avoided, and do not throw the raw material sharp with the sharp edges to the crucible. It damages the crucible. Next one. Scrap charging. Subsequent to the preparation of raw material, next step involves the charging of scrap into the furnace. So size of the scrap is an important parameter to reduce the energy consumption. The scrap charge should be less as dense as possible, lesser the air pocket between the scrap pieces, so that the induction takes place uniformly. So the melt rate is reduced, melt rating is high, and the melting time is also reduced. Otherwise, improper size of the scrap was poured means it takes extra time, so unnecessary energy was wasted. And more is the power density, higher the heat conductivity, faster melting with the least energy consumption. Use small pieces of scrap to the as extended as possible to get the optimum result. Scrap should be charged continuously as the melting proceeds, as continuous charging helps in preheating the scrap. Sometimes if it is possible, preheating the scrap up to 60 degree or 70 degree, so that the furnace energy consumption can be reduced. If any waste heat is produced inside the foundry, that waste heat can be used for the preheating to the scrap material charge, so that the scrap can be increased from the room temperature to the up to 60 degree or 70 degree. The energy consumption in the furnace is also reduced. And the proper charge sequence must be followed. Bigger size metal should be charged first, followed by the smaller size, and gaps must be filled, so that the proper charge sequence is also very important. Next one. Power input. The power input provided for running an induction furnace during its melting operation has an important role. of overall energy consumption of the unit. So run the furnace at the maximum power since beginning of the batch campaign onwards. So the maximum power input increases the rate of melting, and hence it reduces the overall melting cycle time of the heat. Many industries are following because of the demand, available demand. They are not able to give more, the maximum power to the furnace because of the auxiliary loads to be run. So that they compromise for the melting. Instead of 750 kilowatt, they are keeping only 600 kilowatt or 650 kilowatts. So power factor to be maintained nearer to 1, and ensure there is no voltage drop from the source by turnings and borings. So these are the power input side. Next one. Deslagging and sampling. Formation of slag in the furnace wall should be avoided as it leads to increase in energy consumption and decreases the furnace's life. And carry out deslagging once the furnace is full with the molten metal and has attained temperature of up to 1400 degree. Prior to slag removing tools should be brought nearer to the furnace and kept ready. Avoid slag deposition on lining by complete removal of slag. After deslagging, samples should be taken and sent to chemical laboratory. So desaggling and sampling is very, very important. Nowadays, the new foundry developed, built up foundry, they are keeping the this one spectro test result lab is very closer to the furnace area. And the old foundry, the existing old foundries, they keep away so that the spectro result is also takes another 4 or 5 minutes. So during this period, the furnace was kept almost 25% of the rated capacity. So this can be avoided. Next one. Other practices, some of the other practices, these 5 practices is very important. So other thing is avoiding unnecessary superheating of bath and maximize the equipment utilization, maintaining the buffer stock, and production is scheduling is very, very proper production schedule is also required, and proper preventive maintenance, and streamlining the temperature measurement and the sampling. So these are the other best practices in melting. Next one. So best operating practices in melting, do's and do nots. Keep the size of these are the very, very important things. So far we have discussed some around 10 to 11 BOP, best operating practices. And the do's and do nots is very, very important. Keep the size of the charging material to be 1/3 of the furnace crucible size, and do not superheat the material, and operate the furnace at full power and full capacity. Go for maximum compaction of material while charging, and keep the cycle time as short as possible by proper housekeeping. Maintaining minimum holding periods for melt. Separate holding furnaces can be useful for some times. And do not superheat the metal. Don't hold the material in the furnace. It consumes power without increasing in production. Don't uncover the furnace unnecessarily. Avoid long tapping time and the frequency to reduce radiation losses and to reduce the operation losses levels. Avoiding the cap voltage and frequently. These are the do's and do nots. Next one. So basically, the induction furnace is operating principle is like a transformer. There is a primary and a secondary. Here, the secondary is acting as a metal for whatever the raw material given to the crucible is acting as a secondary. The coil is acting as a primary. So the heat is generated by the principle of induction. The high voltage supply is given to the primary coil, is converted into a low voltage, and the high current in the secondary with itself, the metal is melted by the induction principle. The thermal efficiency of an induction furnace generally ranges between 60 to 75%. So this is the furnace diagram. There is a copper casting is there in the outer area, coil is there, insulating material, crucible and spout and metal spout. These are the things. So the basic principle is similar to the transformer. So in a transformer, there is a primary and a secondary is there. Primary, if you are applying 11 kilovolt, for example, in all the HT industry, they are using the step-down transformer. This 11 kilovolt or 22 kilovolt, this high voltage will be stepped down into 433 voltage by the secondary. The same thing in the furnace. The primary coil is acting as a primary. Based on the induction principle, the current induction eddy current loss, the raw material poured inside is acting as a secondary. It was melted. So this is the basic principle of the induction furnace. Next one. So where are the losses are in the induction furnace? AC to DC, again DC to AC converter loss, bus bar losses, water cooled lead losses, induction coil I square losses, conduction losses, radiation losses. The first one is AC to DC, again DC to AC. Normally all the induction furnaces are operated at the voltage of 575 volt. So that you need a separate dedicated transformer for the furnace itself. Nowadays, it is dual secondary transformers are available for the small industry furnaces, so that one secondary is used for the induction side, furnace side, another secondary is used for the auxiliary loads. So this particular AC voltage is feed into the furnace main panel. It's converting from the AC to DC. Again, this DC is converted, smoothening, and again this is converted into AC. And the mid-range frequency furnaces is operating at to 1000 hertz. But in the primary side, we are using only 50 hertz. Whereas the coil side, it uses up to 1000 hertz. That's why it's called as a mid-range frequency. For converting this AC to DC, again smoothening, there is some capacitors are there, filters are there. Again, this DC is converted into AC. So there are a lot of conversions there. Wherever the conversion is more, there are some energy losses are there. The major losses is happening due to this. And another thing is the bus bar, induction, I square R losses, conduction and radiation losses. These are the various losses. Next one. So these are the various factors that will increase the energy usage kilowatt per tonnage. This statistics is the average statistics. Returns with 25 kg ton of stand for 1 tonnage, it leads 12 units extra. And the rusty charge material may be consume another 27 units. Insufficient charge density is also takes 20 units per ton. Recarburizing when fully molten 20 kg per ton, it leads 36 units. And melting with the half power, not a full power, the furnace is not operated with the full power, only half power to 75% means it leads 18 units extra. And heel melting practices is also leads 36. And excessive furnace extraction is also 14 units. So these are the various energy consumption areas. So wherever it is possible, we can reduce. So this is the tentative figure as an indicator to rise the energy usage with 1 kilowatt per tonnage, kilowatt hour per tonnage. Next. So these are the thermal losses due to conductive losses through the lining, heat losses associated with the slag, radiation losses through the openings. Next. So some of the parameters to be measured and monitored: weight of the total metallic charged per batch, and the number of batch melted, and the power consumption in melting, that is a kWh. These parameters to be monitored and measured regularly. Next one. So this is the formula used for calculating the furnace efficiency. Basically, the furnace efficiency is less than 70% only. How to calculate? There is a efficiency formula is theoretical total heat required divided by actual electricity consumed for melting. So we know the theoretical heat requirement is almost 392 something only. So the actual electricity consumed for melting to be calculated in a two way. One is heat required for melting the metal, and heat required for melting the slag, that is H1 and H2. So Wm into Cp into T2 minus T1 plus H is the latent heat, and divide by 3600. 3600 is kilojoules to kWh conversion. If this factor is used, so Wm is nothing but weight of the metal, and the Ws is called as the weight of the slag, and the Cp is the specific heat of the metal in terms of kilojoules per kg degree centigrade. Each and every material like iron, copper, gold, and aluminum, each and every metal is having some specific heat of the metal. So it is represented in kilojoules per kg degree centigrade. And T2 is the final temperature of the metal. T1 is the initial charge of the metal. So H is the latent heat. By using this formula, we can calculate the heat required for melting the metal. So this is the theoretical total heat required for the melting, and actual electricity consumed, we can note it down from the energy meter of the furnace. So by substituting these two values, we can able to calculate the efficiency of the furnace. Next one. Here one simple example. We are melting the MS scrap with the specific heat of 0.682 kilojoules per kg. The latent heat of the MS scrap is 272 kilojoules per kg. It is a constant value only. and the melting temperature is 1650 degree. Charging temperature, the metal is charged at the rate of 30 degree, that is a ambient temperature. Quantity of metal melted 1 ton, that is 1000 kg. And out of this 1000 kg, quality of slag is 25 kg. So the electricity consumed by the furnace is 625 units. So that first we have to calculate the theoretical value. That is substituting these values in the above formula, we can get it around 382.45 units only required for melting this particular material at the rate of 30 degree to 1650 degree. And for the slag also it needs another 11.45 units. So totally the heat requirement is somewhere 394 units only it is required for heating the metal from 30 degree to 1650 degree for melting the metal 1 tonnage. But practically it needs 625, so that the efficiency is nearly 63% only, because 394 divided by 625, it gives around 63%. So this is your efficiency of the furnace. The same thing you can able to calculate. Only thing, the slag quantity collection is only difficult. Maybe you can collect it in day wise, and day wise how many melt you can take, and the entire value can be substituted, and the total electricity consumed by your energy meter installed in the furnace may be calculated in a day. For example, in a day you can take 20 heats, means for the 20 heats how much metal you have melted, what is the temperature, average temperature range, what is the average slag rate generated. By applying this you can able to calculate your own furnace efficiency. Okay, next one. So some of the case studies implemented in Coimbatore cluster through our project, we are discussing case studies in melting. So the first one is best operating practices in furnaces. Two things we done. One is sintering practices and the raw material charging pattern. In the existing practice, the sintering was followed as well as seed thickness high. Thickness is very high. That is a 3 mm is recommended. And the fork tool also found not proper. And the GLD dimension is not proper. And the basement ramming mass height not measured during the sintering practices. That is this one lining time. So it will lead this best operating practices, no, reduce the specific energy consumption for liquid metals up to 8%, increasing the melting efficiency, and the melt time is also reduced up to 10 minutes. Energy saving per heat is approximately 30 units per ton. So the existing practices, they used to having this following step: 0 kilowatt for 60 minutes. The GLD current is also noted. The new procedure is 0 kilowatt for 60 minutes. GLD current is noted regularly. And the second one is 50 kilowatt for 60 minutes continuously in 1 hour. 50 kilowatt was maintained by the power capacity in the furnace. The new practices is for 1 minute 25 kilowatt was given, and 9 minutes it was of 0 kilowatt. It is repeated for 60 minutes. That is every 10 minutes, 1 minute 25 kilowatt, 9 minutes 0 kilowatt. Again 1 minute 25 kilowatt. So 6 cycles was repeated, 25 and 0 kilowatt. Similarly, same way, the power capacity is gradually increasing compared to the existing one, from 25 to 50 kilowatt, again 50 to 75 kilowatt, 75 to 100, 100 to 125 kilowatt, and the timing is also increasing from 1 minute to 2 minutes, 2 minutes to 3 minutes, 4 minutes, 5 minutes. This is the practices we followed, and finally holding for 60 minutes at 0 kilowatt, and finally the metal was tapped. So next one. So charge pattern, raw material charge pattern. In the existing raw material charging pattern, pig iron is used 250 kgs, charged at full power, that is a 350 kilowatt furnace capacity, and the borings 150 kgs added in the phaser manner, and the foundry returns spillages is added 100 kg and 90 to 100 kg. This furnace capacity is 500 kg, but they are taken up to 550 to 580 kgs per melt. So this is the existing practices followed. The proposed raw material charging is first in the base, the empty crucible. Now, once the metal is taken out, the borings was put for 50 kgs. Then the next layer, pig iron 100 kgs added. The third layer 50 kgs added. Again 50 kgs of pig iron is added as the sequence. After charging all this 250 kgs of material, then the furnace is setting as a full power, that 350 kilowatt. Then the melting is happening. Once these particular 250 kgs of metals are melted, then the borings is 50 kgs added in the phaser manner, and again pig iron is added 50 kgs. Next is borings is 50 kgs added, pig iron borings. So finally foundry returns 100 kg added. So spillages is also, this is the new pattern followed in the raw material charge pattern. Next. So in the existing pattern, this graph says this is the power quality analyzer we have. There is a energy power quality measurement instruments we have through our project. So I studied in the existing practices. For one melt, it takes around 472.5 kilowatt. For melting, almost 550 to 580 kgs of raw material. Molten metal was taken as a 570 to 580 kgs at the 350 kilowatt furnace. For one batch, it consumes nearly 472.5. After this new sintering practices and the raw material charge pattern, the same foundry achieved nearly 441.2 units. So almost in 550 to 580 kgs of liquid metal, they are able to reduce nearly 30 units per heat. So due to this proper sizing of raw material charging sequence and also the best practices adapted in the sintering practices. Next one. Next one is same thing, best operating practices in raw material charging itself in another foundry. So this graph shows the existing is pig iron 50 kg, CI borings 600 kgs, foundry returns 300 kg, LMS scrap is 50 kgs. The furnace capacity is almost 1 ton, 750 kilowatt. The proposed raw material charging is first pig iron 20 kg, CI borings, foundry returns and LMS scrap. So the pig iron quantity is increased. Earlier they used only 5%. Now it is increased to 20%, 5 to 20%. Next one. Here the energy consumption is reduced for the based on the data. Averagely they taken 622.7 units per ton in the earlier stage. Now this new raw material charging sequence pattern they reduced to 610. Average is 610. So some of the basic heats we taken. So almost 10 to 12 units per ton it can be reduced by the charge sequence itself. Next one. Case study power setting. So one of the foundry, they are having some problem with the demand, maximum demand. So they are sanctioning almost somewhere 1150 kVA something is there. So the furnace capacity is 750 kilowatt. But due to this demand rising, they have to pay the extra penalty to the EB now. That's why the foundry units was using this power as a 600 kilowatt. So we suggested study the entire auxiliary loads and mains also for 1 or 2 days. We suggested to increase another 50 kilowatt, but the safer side, the foundry was setting from 600 to 630 kilowatt. 30 kilowatt additional power has to be given into the furnace area. We are taken the completely entire day before and after. At the 600 kilowatt setting, the furnace average specific energy consumption is somewhere 644 units per ton. Whereas for 630 kilowatt setting, the same foundry was achieving nearly 617 units only. Here we can able to tell almost 24 plus 3, 27 units can be saved in a per heat. So here the melt timing is also reduced up to 5 minutes. So increased metal output can be taken. It's 750 kgs extra melt can be taken, and the specific energy consumption of the liquid metal is also reduced up to 9 to 10 kilowatt per metric ton. This 644 and 617 is for the complete melt sequence. Here the SEC is also reduced up to 9 kilowatt per ton. Next. Best operating practices in melting, same thing. This one dual track furnaces with load share, mono track with the lower power, and the load sharing is happening earlier 1000 kilowatt plus 250 kilowatt. Now it is given as a full power as a 1250 kilowatt. The main thing here is the solid material is charged first, then the MS scrap is added, and the carbon addition is happening third. CI borings addition, adding the scrap materials 40 to 50 kgs at regular interval, and the CI boring is addition. And the main thing is the poking the slag at a regular interval, so that this will happen in the periodic way. So the slag to be removal at the regular interval, poking is done at the regular practices. At 90%, the metal to be tested to the spectro. And meantime, they adding the runner and risers. Once the spectrometer result came, all the chemical composition material metallurgy is achieved, then the material is tapped. So by using this, the unit was saved almost 732 units in the existing practices. Now the new practices, they achieved nearly 700 kilowatt per ton. Only thing they have to change the charging pattern and poking and some best practices adapted in the melting area, so that they can able to save almost 30 units per ton. Next one. So this is the actual figure, the same foundry. We are taken completely for 3 or 4 sequence of melting. It takes almost 2,645 units consumption. The raw material charged is almost 4,250 kgs, and energy consumption is 2,645. And overall specific energy consumption is 688 only. So compared with this old data, January, February, and March, in the month of April, 752 units, May 2021, 756 units per ton. In June, they reduced to 700 units, and individual melt also the data deficit only 668. So on an average, the unit was reducing nearly 35 to 40 units per ton because of this poking and best operating practices adapted in the melting alone. Next one. So these are some of the data revealed through TERI only, the Energy Resource Institute, because the TERI was working in our cluster for various projects. Actually, this case studies were taken from the TERI reference. So by using the performance optimization of induction furnaces, by using the small sizes of MS scrap for charging, they saved nearly 27,503 units per year, and 2.1 lakh per year is the cost saving. And due to this energy saving, they achieved 27 tonnage of CO2. So 1 tonnage of CO2 is equivalent to 1080 units. If you are saved 1080, you can claim 1 tonnage of CO2 emission was reduced. As the carbon footprint reduction, this data can be used. Next. So replacement of the old induction furnaces with new energy efficient IGBT induction furnaces, they can able to save 1,20,000 units per year, and 9.1 lakhs savings per year, and 118 tons of CO2 emissions can be reduced in a year. Next. Reduce radiation losses. So by reducing the radiation losses, 25 units per ton for 500 kg crucible melting at 1450 degree can be saved. So by using lid mechanism for induction furnaces, it can reduce the radiation losses and improves the workplace environment also. Next one. So for reducing the radiation losses, this case study is also taken from the TERI reference only. By using this proper lid mechanism, this is the customized by the industry itself, so they can avoid 23 units per ton because of this lid mechanism. So the radiation losses is reduced. Next one. So in this foundry, 9 units per ton was reduced due to this lid mechanism. Next. So far we are discuss about the various best operating practices in melting, because 70% of the energy was consumed in the melting area. So the next one is third topic is best operating practices in mortars. Next. See, normally in any industry, the motor load is very, very high, irrespective of any production. The motor is very, very major element in all industrial activities. So basically, the motor efficiency depends on this kind of thing. One is there are core losses. Normally, it is called as iron losses, and the stator winding losses is called as a stator resistance loss, and rotor loss, and the windage and the friction loss. Basically, windage and the friction loss is very, very less only, and the stray load losses. These windage and stray load losses is less than 1.5% only, but the remaining iron core and the stator rotor is very high. So approximately this particular motor was the data shown as a IE3 motor. That is an international efficiency. IE is called as a international efficiency. Now Bureau of Energy Efficiency and the government is also recommended to industry to install the energy efficient motor. Now don't go for the inefficient motor. So if you are given input power 100% mean the effective output is 92.4%. Remaining 7.6% is gone for the various losses for the even IE3 motor also. If you go for the same motor, for example, this is a 50 HP motor with IE3 motor. The efficiency is almost 92.4%. The same motor can be replaced with IE4. The efficiency figure may be 94.2%. Another almost 1.8% output will be more, with less 1.8% can be achieved. But the thing is, the cost of the motor IE3 to IE4 is quite high. So based on the applications and usage, the foundry can be decided whether we can go with the IE2, IE3 or IE4. For example, for particular motor was running for only 2 hours per day. So installing IE4 is very high expensive. Maybe you can installing IE2 motor for particular section. Whereas in the cooling tower, cooling pumps, no, that pumps for using the induction furnaces, it is running continuously for the 24 hours in most of the foundry industry. So those furnaces, those pumps can be, motor can be installed with IE3 and IE4 because the running hours is very high. So that the investment cost and energy saving cost is very high. So that the payback period is very less. So based on the needs and based on the application, the foundry and maintenance team and the purchase team can be decided whether we can go for IE3, IE2 or IE4. Based on the operations, we can select. Next. So this is the life cycle cost. It is applicable for not only motor, it is applicable for air compressor and any energy consuming equipments. The life cycle cost is very important. So out of this 100%, the energy cost is here. This graph is says 97.3, but normally it says almost 90 to 93% of the whole cycle cost. It gone for only energy. So 2 to 3% for the initial investment cost. Remaining cost is for the maintenance cost. So the major area is energy. So that based on the applications and requirement, the unit can be decided go with the energy efficient motor. So very, very important. Next. So the electric motor, some of the energy saving tips is for every 10-degree rise in the motor operating temperature over the recommended peak, the motor life is estimated to be halved. You can check it with the thermal meter. It is used in the corona temperature testing. No, the same thermal can be used for checking in the motor body. So as per the specification, if the temperature is raised, then every 10-degree rise will reduce the life of. So it will be taken in a very stringent. And the rewinding is not done properly means the efficiency can be reduced by 5 to 8%. Basically, in all industry, if any motor fails, it gives to the local workshop or in-house team. Mostly it is given to the local workshop only. They dismantle the motor and rewind. So once the motor is rewinded, that means dismantle and again assembled with the local workshop, then automatically the percentage of the efficiency will reduce to 5 to 8%. Many foundries, they are using more than 5 to 6 times rewounded motors are used. As per the BE recommendations, only 2 or 3 times only the motor should be rewounded. After that, it can be scrapped and we have to use the new motor. But in practice, it does not happen. So every time the motor is rewinded means minimum 5% efficiency is lost. At least 5 times if you are rewinded means minimum 20% efficiency will be lost, so that we are using more energy. So this is not noticed by the management. So it is very, very important. So we are losing more energy loss in the rewinding area. So that 2 or 3 times only the motor to be rewinded. And most of the foundries, they are following the TPM and other preventive maintenance schedules. The history card should be noted once the motor is rewinded, the date and area to be noted, so that the motor should not rewounded more than 3 times. So the maintenance team should be very alert for the rewinding the motor. And wherever it is possible, variable speed drive option can be used so that it can reduce the energy consumption by 5 to 15%. In some cases, more than, especially in the fans and blowers, you can achieve 25% also. This is also based on the application. So the variable speed drive is also saved in minimum 5 to 15% of the energy. and in some pump and fan application, you can save up to 35%. So wherever it is possible, the VFD can be adapted. Sometimes it is called as a variable speed, the VSD. Basically, in commercial term, it is called as a variable frequency drive. Next one. So these are the energy efficient motor inside. They use lower loss silicon steel, longer core, thicker wires, thinner lamination. There is a air gap between the stator and the rotor, and improved winding and the lamination designs to minimize the energy consumption. These are the steps taken by the original equipment manufacturer OEMs for making the energy efficient motor. Next one. So basically the efficiency is nothing but output power by input power. So normally the motor is rated as 10 HP means what it is. So motor is rated 10 HP means in the shaft it was produced 10 HP, so that 7.5 kilowatt power can be delivered in the shaft, so that the input power is high. So based on this efficiency level, for example, one 10 HP motor with 91.2% efficiency, then what is the input power means? 10 HP is 7.5 kilowatt was developed in the shaft side only. That is output. Whereas the input is 7.5 kilowatt divided by efficiency of the motor is 91.2. So 0.912 means it comes around 8.8 kilowatt is the input power. So the meaning is 7.5 kilowatt is consuming in the mains 8.8 kilowatt means this is the actual fact, because the motor shaft power only the nameplate determines, nameplate indicates 7.5 kilowatt or 10 HP, whatever the HP or kilowatt rated was mentioned in the nameplate. It was denoted as a representing the shaft power only, not the input power. If you want to calculate the exact input power means what is the nameplate rated kilowatt divided by the efficiency, you get the input power. This is the simple example. For example, 10 HP, 7.5 kilowatt, 91.2% efficiency motor means it can take up to 8.8 kilowatt. This is the thing. So based on that, you can calculate the motor efficiency. So efficiency is nothing but output power by input power. Next one. So these are the various options for the energy efficiency opportunity. Use energy efficient motors, reduce underloading, avoid oversized motor, power factor corrections by capacitor. More than 25 HP motors can be filled by the capacitor whenever the starter is started, start to delta conversion. During the type small capacitors based on the calculations you can install, so that the voltage rating is also increased, and avoiding rewinding more number of times, and improve voltage unbalancing. Speed control of induction motor wherever it is possible, VFD can be adapted. Optimizing the transmission efficiency, and proper maintenance and improve the maintenance activity. These are the various energy efficiency opportunities. Next. One of the case study, the existing motor can be replaced with the energy efficient motor. This is the pump application. So the delivered output is same here. Both the delivered output is 23.37 kilowatt only. Whereas in the existing motor, it consumes 47.2 kilowatt, because the motor efficiency is 90%. So that the input 47.2 kilowatt is converted in the output 42.5. Again, the pump efficiency is same 55% only, so that the delivered output is 23.7 kilowatt in the pump output. Whereas in the energy efficient motor, it takes only 44.7 kilowatt. So the motor efficiency is high, so that output is 42.5, input power is less. So the same delivered output is there. So the thing is, from 90% to 95%, the efficiency is increasing. The energy consumption is somewhere around 2.8 units can be saved due to this energy efficient motor per hour. If the pump is running for 20 hours means they can save around 20 into 2.8, 28 plus 28, 56 units can be saved in a day into 300 days. This much energy can be saved. Next one. So best operating practices in the pumps and blowers. Next. This is also one of the pump example only, well designed and actual design. So various losses it is associated. So the motor efficiency is 95%, pump efficiency is 85%, and head loss, that is throttling 20%, and the losses and the leakage, some quantity is there. And here the actual existing motor, motor efficiency 80%, pump efficiency only 70%, and the head loss is 50%. Compared with the well-designed is only 20%, whereas the old pumps are 50%, and the losses. If you compare both the things, the actual designed, well-designed pumps are very less energy consumption compared to the existing thing. So you can prepare the proper pumps and motors for the particular application, and the throttling is also leads more energy consumption. So wherever it is needed, VSD can be adapted to reduce the speed according to the flow control. The VSD can be used to reduce the speed. So once the speed is reduced in the motor, 10%, if the speed is reduced, 27% of the energy consumption was reduced. It is based on the affinity loss by the thing, physical parameter. 10% speed is reduced, flow is reduced by 10%, and the head is reduced by 19%, and 27% is the energy saving can be achieved by reducing the 10% of the speed. Next one. So this particular case study was implemented through our project. This foundry was operating 24 hours. In the existing, they are using 25 HP KSB pump. They are used with the LG motors. We suggested to replace with the 20 HP Grand Force make energy efficient pump and motor with the pump. Next one. So the existing is 25 HP, present is 20 HP, and the motor efficiency 90. The new pump motor efficiency is 91. Existing pump efficiency is rated is 68, but actual we don't know. We cannot be able to measure the flow rating and other things. If we are able to measure all the flow rating head, means we can exactly save the existing pump efficiency, and the new pump efficiency rated is 76. The current drawn by the motor is 26 amps. This was taken through our energy analyzing equipment. The new pump was consuming only 19 amps only. So the average energy consumption is 16.2 is the old one. The new pump is taken only 11.6 kilowatt. The same pump was delivered to the furnace, entire furnace. It's a tri-track furnace. So without no problem, the furnace was operating. So here we can able to save around 4.8 units can be saved in an hour. The furnace is continuously running. So the next one. So this 16.2 is the existing pump energy consumption for 1 hour. So this data is taken on the 2019 January from 1240 to 140. Exactly 16.2 units was consumed. Next one. So they can be able to save 4.8. So in this graph, it says as a 5 units. So the existing is 16 units. The new pump was consuming 11 units, and the saving is 5 units per hour. Next. So this is the cost economics. So approximately they save 7,200 hours running foundry, means 33,120 units can be saved because of this one pump itself. The cost saving is 2.48 lakhs. The investment cost is 1.1 lakhs, and the payback period is 5.3 months only. So less than 6 months the payback was achieved due to this energy efficient pump. Next. So productivity restoration through belts and pulleys. Now we are doing more number of especially short blast machines and dust collection systems. No, belt and pulleys are ignored area in many industries. So we can able to restore the productivity, because what happens means there is a driven pulley and a motor pulley. There is a design, as per the design, the mechanical efficiency to be properly transferred, whether it's a short blast or a dust collection system. But practically what happened means over a period, the belt was, it's not in the proper condition, and also more cutting is there, so that the more slippage is there. If the more slippage is there, it will need more time. For example, short blast machine, and the OEM says 5 minutes per batch. But due to this not effectively transfer the mechanical efficiency, gradually the people is rising the time from 5 minutes to 10 minutes, even 13 minutes also. So unnecessarily, we are running the short blast machine for another 5 to 7 minutes period. Once the same motor and the same system, we are adapting the best pulley and belts with the cogged edge belt system, so that they can able to restore the productivity by means of reducing the slippage. So once the slippage is reduced, automatically the productivity increase. So far we are implemented nearly 5 foundry units for the salt blast machine. They are able to reduce from 10 minutes to 7 minutes. So one unit was reduced from 12 minutes to 7 minutes, so that approximately 4 to 5 minutes per batch can be saved. So the same manpower, same machine, the extra salt blasting process can be done. The overall specific energy consumption, the energy consumption is less because we are taken more salt blasted output, so that the energy consumption is reduced. So these are the advantage. So restoration of through belts and pulleys. Next one. So this is the existing and the present. So before changing the pulleys and belt, the more particularly it's a 20 HP, 15 kilowatt. Number of motors is 3 motor. This particular example is now I am discussing with one salt blast machine only. The motor speed is 1470 RPM. New also because we are not changing the motor, only the pulley and the belt was changed. So existing pulley size is 200. The new pulley size is 190 with the taper lock pulley, and belt is B type Fenner type. Now it is converted into cogged edge belt XPB 4XPA Mitsubishi. The existing belt is 3 belt. Now it is replaced with the 2 belt, and batch timing is existing 8 minutes. Now it is a 5 minutes only. The energy consumption per batch is nearly somewhere 4.33 units, and the number of batches is 20. So we can save that around per batch nearly over 1.4 to 5 units can be saved. Next. So energy saving per batch is nearly 2 units per batch, and 25 batches taken per day means 40 units they can able to save, 40 to 50 units. And the energy saving per year is 12,000 units per year. Cost saving is nearly 0.96 lakhs rupees. Investment cost is 0.4 lakhs rupees, and the payback period is only 5 months. Next. So next topic is best operating practices in air compressors. Next. So air compressor is a very expensive. There is a thing was discussed in industry. Air is free, but air compressed air is not free, because compressed air is more than 3 times costlier than electricity, because this is the Sankey diagram of compressor. So any thermal energy representation can be represented through the Sankey diagram. Here there is a flat blue layer is there in the bottom area. So whatever the input power is given, the effective air is converted only maximum is 15%. Remaining 85% is gone for various losses for generation, treatment, and distribution, and the moisture. All those things is take away by remaining 85%. For example, we are having 100 HP air compressor, 75 kilowatt means we are producing only 15 HP compressor air only. Remaining 85 HP is gone for various losses. So that air compressor is very expensive energy equipment. So there are lot of potentials are there for reducing the energy. So up to 20 to 30% energy saving can be possible by simple energy saving measures and air leakages arrest at regular interval. The FAD is nothing but free air delivery. It can be increased up to 12% by cleaning regularly the inlet and outlet filter air filters. Next one. So this is the recommended typical ring main system layout for the compressed air system. Next. Next. So to performance assessment of any compressed network, these are the instruments we needed: power quality analysis or energy meter for noting out the unit consumption, and pressure gauges and anemometer, IR thermometer, ultrasonic leak detector. This leak detector helps us to quantify the leakage quantity. Next. Best practices in compressed air. Some of the tip is set the optimum pressure. So 1 bar reduction gives 6 to 8% of the energy saving. So during unloading condition, motor consumes 35 to 40% of the energy consumption, and go through especially in the screw compressor, there is a panel is there, HMI panel. You go through what is the loading hour, unloading hour, and the running hours. If any compressor is loaded below 70%, that is below 70 to 80% below, safer side 70%, unloading is 30%, means there is a potential for retrofit the VFD to reduce the unloading power, because whenever the compressor is running, during the loading time only it was generating the air. Unloading time the air is not generated because the cylinder is not get activated with the motor. Only the motor is ideally running. During this period, the rated current power of the motor, 35 to 40% of the rated power will be consumed during this unloading condition. So wherever the loading and unloading pattern 70-30 below 70% means definitely we can go with the VFD. And also the intake air must be very, very cool. So especially in foundry area, there are lot of heat area is there. So the utility room must be very clean. So every 4-degree reduction, it will give 1% of power saving. And clean the air filters at regular interval. Replace the oil filters at regular interval. Avoid cleaning with the compressor air and use portable blowers for cleaning pressure. So electrical blower can be used for cleaning wherever it is possible. Next. So optimize the cleaning pressure as 2 kg per centimeter square. No company, nowhere it was not used. Only few of the companies are using the filter regulator lubricator, FRL, or sometimes regulator they reduce the air pressure for the cleaning pressure. But most of the industries are using the line pressure only. Whatever the pressure was generated by the compressor, 7 kg or 8 kg, that can be used for the cleaning. And replacing the energy efficient screw compressor from reciprocating them. Still, many small industries and micro industries are using the reciprocating type. So reciprocating type, the FAD is very, very low, because reciprocating is generating for 1 HP nearly 3.5 CFM only, whereas the energy efficient latest IPM model, that is the internal permanent magnet motor, compressors are generating nearly 5.5 to 5.8 CFM per HP. So the old reciprocating can be replaced with the screw compressor. And the VFD can be implemented for above 30 HP wherever the loading and unloading problem is there. And the ring main system reduce the air losses. Use small air compressors if major production load is solved, especially in Sundays. Only small portion of the company was running, means the main compressor cannot be used. Only small compressor can be used for the particular section, so that you can save lot of energy. And the proper drain walls should be retrofitted in the system. Otherwise, the moisture will leads the cylinders and other activities with the air, with the water. It will break down the machines, and more maintenance activities to be done during this thing. So the proper moisture control and the drain controls to be installed, and the leakage study to be conducted at regular interval, and the preventive and the predictive maintenance to be carried out at regular interval. Next. So specific energy consumption. So for the 50 HP screw compressor delivered 200 CFM at 8 bar with service factor 1.15. Normally the compressor manufacturer says the service factor is 1.15, 1.2, sometimes 1.25. So that based on that, the energy consumption per hour is 37 kilowatt. That is 50 HP is nothing but 37 kilowatt. 37 into service factor is 1.15 divided by 200 CFM, means the specific energy consumption is 0.212 kilowatt per CFM. Still it is very high. Nowadays, the manufacturer says only 0.16 kilowatt per CFM CFM generation. And practically at the rate of 70% loading and 30% unloading, the energy consumption is 26.6 kilowatt. And the CFM rating is also only less than 120 CFM only. So that the specific energy consumption is very high, because 26 divided by 120 means the CFM specific energy consumption is very, very high. Next. Power reduction through the pressure reduction. So the second thing is the optimized pressure. Now every 1 bar reduction is gives 6.8 6 to 8% of the energy consumption is reduced. See here some of the table says the average air pressure reduction is 0.5 bar, 1 bar, 1.5 bar in the this one air pressure rows, and 4 kilowatt means for 0.5 bar reduction will yield per year 320 units. And same thing, 2 bar reduction will give 1280 units, whereas 15 kilowatt machine is given nearly 2390 units at the rate of 1 bar. and for 1.5 bar reduction is also gives nearly 3,580 units can be saved. So that the air compressor generation pressure side will be very cautious. The optimum pressure should be settled in the generating side. Most of the foundries and the manufacturing industries, they are operating 10 bar, loading at 8 bar and unloading at 10 bar, but actual usage in the process area is only 6 to 6.5 bar only, so that they can able to reduce the generation side itself 6.5 to 7 bar. So there is no losses in the pipeline and no air leakages is there, so that they can easily set below 6.5 to 7 bar loading and unloading, so that they can able to achieve the best pressure rate in the farthest point of the air network within the foundry, so that the lot of energy saving can be done. Next. Pipe sizing is also very important. For a 200 CFM at the rate of 8 kg pressure means the pipe size should be minimum 2 inches pipeline should be provided. So there are some thumb rules are there. If the pipelining is bore diameter is increasing, the losses will be reduced. The graph says at the rate of 50 mm bore size, that is 50 mm means almost 2.25 inches, the power losses will be 2000 watts, that is 2 kilowatt. If the same thing is reduced to increase the pipe size into 80 mm means the pressure power loss will be less than 200 watts only. Almost we are saving nearly 20 times we can able to save. So that depending on the furnace, foundry company nature, the pipeline should be very optimized. So whenever the new machines is added in the company, they keep on adding the pipeline in the same existing pipeline, so that proper calculations to be done for the piping network also, so that you can save some lot of energy in the piping sizing also. Otherwise, you can set the pressure rating to be high. So this is the thing was happening. That's why the most of the industries are running the generating the compressor at the very higher pressure rate, because the proper sizing was not done in the foundry premises. So that's why the generating pressure was keep on rising. Next one. So these are the various size. So you see the 40 mm bore size, the pressure drop is 1.8 and the equivalent loss is 9.5 units. So the same thing, 100 mm bore size means only 0.02 bar only pressure drop. So that it leads only 0.1 kilowatt only loss. How much kilowatt they can able to save? So that the piping should be very important. So for the smaller pipe diameter, the energy wastage is very high. So the optimum pressure pipeline diameter to be installed. Next. So the another thing is leakage. So leakage is typically in all the industries are there. Normally the recommended leakages should be below 5%, but practically it is end up with more than 20% only. Some units are having some 30-40% also there. So every leakage will be costlier. So here there is a 1 mm size pipeline. In a pipeline, there is a 1 mm hole is there. So the leakage is nearly 75 liters per minute, and energy loss is 0.6 kilowatt per hour. In a year, 34,560 units was lost. Same thing, 3 mm hole dia, it will lead to 600 liters per minute. Every hour, they lose 4.4 kilowatt, and 2,53,440 rupees is the air loss. So that for this is for the single point. The 3 mm hole size is almost some 10 losses in a factory. So imagine how much amount they are losing due to this air leakages. So how to calculate the air leakages means you have to calculate the loading time and unloading time. Put the values in the T by divide by T plus T. T is the loading time, divide by T is again loading time plus the unloading time. So this performance to be done during the plant ideal condition only. That's one time only we are able to say. Normally maintenance people is conducting this air leakage study during the shutdown time or Sundays only. So they are taking the loading and unloading time with the watch timer. so that for 1 hour they have to take how much loading and unloading takes place. Normally, in a typical very good without leakage system means once the compressor is loaded, the air receiver is filled, there is no air consumption inside the plant. The loading should be not happen and the motor should be off and the compressor should be ideal condition. The practically in many places the leakages is there. The air is leakaging from the hole and the leakage point, so that the pressure will be reduced. Again, the compressor is loading and goes to unloading. So unloading is more important. So the compressor should be unloaded and should be off. If there is a more loading is happening, that means your plant is having more leakages is there. This is the one indicator. So during the air leakage study, the compressor should be off condition for more than half an hour or 1 hour if there is no air leakage. But practically it is not happen. Based on the leakage quantity, the loading and the unloading is happen. Next. So some of the projects was implemented through our project. So this is one of the project was implemented in one of the foundry. So we are Visa Foundry, name it is called in Coimbatore only. We are changing the total compressor, generation side, pipeline, air receiver, and the cleaning pressure. We are separately lay the line, and the cleaning pressure is also maintaining below 3 kg pressure, 3 bar pressure. So the total investment cost is nearly 16 lakhs. Our project was supported financial of almost 4 lakhs. 4.8 lakhs is given for the company to encouraging them to implement the energy efficiency technology. See, the existing, they have 90 HP compressor, one is 50 and 40, approximately 870 units they consumed. Now we proposed and implemented one energy efficient IPM model compressor make. It's a BAC make with the inbuilt VSD made. So it consumes only 630 units per day, nearly 240 units they are able to save. Next. So existing operating pressure and now operating pressure. So 7.5 bar is loading and unloading is 8.5 bar. Now they are loaded at 6.5 and 7.4 is unloading thing. And the air dryer is new one and the air receiver is also 4,000 liter new air receiver was installed. Next. So this is the project inaugural by Director General of BEE. Next. So this is the cost saving. So nearly 5,925 units they are able to save in a month. And for the liquid metal angle, the existing compressor is consumed nearly 50.1 units per ton. Now it is consumed only 29.1. So 21 tons of 21 units are saved per ton for the liquid metal, kilowatt per metric ton in the auxiliary loads. Next. So the overall impact is energy saving per year is 71,100 units. 5.7 lakhs is the saving. So the total investment cost is estimated is 16 lakhs, but actually it is completed with 15.15 lakhs only. So the payback period is 32%, 32 months only. Next. Next one is the existing compressor 40 HP will be replaced with 30 HP screw compressor with the inbuilt VFD. The old compressor 40 HP was consumed 710 units. The new compressor consuming only 500 units per day. Next. So this is the cost saving. Every year they are able to save 1,56,000 units and investment cost is somewhere around 8.66 lakhs and the payback period is also very less. Next. Another example, one more foundry, they are having one small screw compressor and the rest of the things are reciprocating only. So all the existing compressor was replaced with one single compressor. So they are able to save nearly 1,38,000 units per year. And the cost saving is 11.4 lakhs, 11.04 lakhs only. So all put together compressor, receiver and the air dryer, the investment cost is somewhere around 10 lakhs. So that the payback period is only 11 months only. Next. Pressure optimization. Earlier I told due to this pressure minimization, one unit was this is the pump industry. So the pump industry was operating the small compressor, 15 HP compressor, 11 kilowatt, at the rate of loading at 8.5 and unloading at 9.5. During this existing pressure setting, the current taken by the compressor is nearly 21.6 amps. We reduced this pressure setting to 7 to 8 bar. 7 bar is the loading and unloading at 8 bar. So 18.6 is the current consumption. So 3 amps was reduced. So energy saving per day is nearly 13 units because this particular unit was running for only 12 to 14 hours only. So we are accounting for only 12 hours. So without investing any amount, only the pressure reduction, they are able to reduce 13 units in a month, 330 per year, 4,050 units they can able to save. There is a no investment. Without investment, they can able to achieve 30,420 rupees per annum. If the unit was running for 24 hours, means this value will be double. Next. The same type, another company, they are operating the higher pressure setting and the loading and unloading. We are reducing to 7 to 8 bar. So they are able to save 30 units. This is the actual recording taken in the existing and our pressure reduction after implementing the pressure reduction. So existing, it consumes 31.31 units. Now the new pressure setting 7 to 8 bar, the same compressor is operating 9.56 only. So here also there is no investment. Approximate cost saving is 9,360 units and 65,520 rupees they can able to save. This cost value was arrived at the rate of 7.5 rupees in the old tariff. Now the new tariff is more than 8.9 rupees per unit. Next. So this is another example, common VFD adapter for the two compressor. So any one compressor only running at the time. So they are able to save another 73 units per day. So nearly they can save 21,600 units per annum. So the payback period is also very, very less, only 9 months.
Sivakumar sir, we are going a little bit over time, sir. Sorry, sir.
Yes, sir. Yes, sir. Okay. Okay, sir.
Please.
Okay. Okay. Next. So these are another thing is 90 kilowatt VFD implemented in one compressor. There is a 70% loading and 30% is the unloading. Actually 65% is the loading and 35% is unloading. Once it is retrofitted, they can able to save 360 units per day. Next. Next. So here another one example, there is a air booster. So one company was manufacturing the pump component. Because of this coil forming machine, particular machine needs more than 10 bar pressure. So that the entire compressor pressure was raised to 11 bar. So we can suggest it to install the air booster so that whatever the input air is given, it is a double time. So the entire air pressure setting was reduced. So this investment cost is only 50,000 rupees. This company is also running for 12 hours only. So the payback is only 1 year. Next. So this is the benefit. So the pressure bar is reduced. So the inlet is 5 bar. The air booster output is 10 bar. So approximately they save 24 units per day. So the investment cost is 50,000. The cost saving is also almost 50,000. Within a period, they can take the investment cost. Next. So next. So can we go through with the energy audit, sir, or otherwise we can wind up? Hello.
Sir,
Hello.
approximately how much time it will take, sir?
Maybe another 10 minutes, sir.
Sir, already we are at 4:20, sir.
Yes.
I think we can wind up.
Okay, sir. So I will completing this one only, sir. So in the air compressor network, there is IoT-based monitoring systems are available. So these kind of device will give what is your compressor generation efficiency, what is the leakage quantity. All these things can be monitored in your IoT-based system. So this system will help you whether we are effectively running the compressor or not, or how much energy we can waste it. So based on your input, some activities you are done for the energy saving methods. No, this can be used for saving the energy as well as to monitor and calculate the efficiency also. So
Sir, Sivakumar, sir, you can
Yeah.
continue, sir. You finish it.
Yes, sir. Yes, sir.
You can
Next.
go ahead.
Yeah, next one, sir. So this is a compressor pipeline. In the existing pipeline, this mass flow type of sensor was fitted, and one pressure sensor is fitted in the another line. There is a half-inch ball valve is used. The sensor length is only 200 mm. So the sensor to be inserted minimum 20 mm or 15 mm inside the pipeline, so that the air pressure was generated at what CFM was given by your compressor can be exactly monitored by the system. For example, if your company was implementing 50 HP compressor, the compressor may be old, more than 5 years old. It's a screw compressor. As per the OEM commitment, the compressor will be generating nearly 220 CFM. Whether this 220 CFM is generating or not, by using these techniques, IoT system, you can able to monitor, and also what is your air demand inside the plant, what is your requirement, and the same system can be used for leakage also. In lunchtime, maybe 12 to 12:30, the machines are not used for the auxiliary equipments. The whole foundry was not operating except melting. So during this particular time, what is the air leakage quantity in CFM can be arrived due to the system. And another important feature, if the air compressor is having energy meter, the same energy meter is incorporating in this IoT system. You can able to quantify how much energy you are lost due to this air leakage, and how much energy, specific energy consumption you are developed during the CFM generation, air generation. Every day, every hour, every minute also you can able to monitor. So this is the excellent kind of system. Whenever I am doing the energy audit, wherever it is possible, I am using this system. This system was getting from outsourcing, so that he was coming, and they are extensively done this system, and our energy audit reporting is also very much enhanced due to this thing. Next one. So this is the output. See, 1, 2, 3. This is the various date. What is the maximum CFM generated? What is the average CFM consumed? What is the maximum air pressure was maintained? And what is the loss? How much losses there in the pipeline? Everything was arrived. So here, the kilowatt per CFM is 0.25 kilowatt. Next day 0.25. The third day 0.26. So this kind of measurements you can able to take, and this is the maximum kilowatt consumed by the compressor, and what is the average kilowatt, what is the minimum, the total CFM, the total units, so that the total units divided by total CFM divided by total units means it will give the kilowatt per CFM. So this way we can able to give the figure to the management also, how the performance of the compressor is there. So this is the best system by using the adapting the IoT systems. Next one, sir. So this is the same thing. Next. Same in the graphical pattern. What is the pressure CFM with respect to every minute? What is the pattern compressor generation? Next. So this is due to the leakage. See, during that break time now, the timing is 5th August 2020, 14/7. That is 2/7 to 2/22. There is a breakage, a T breakage. That time nearly 64 CFM is the loss from the 100 HP plus 100 HP. 200 HP compressor is running for catering the air demand for the foundry. So during this period, 64 CFM was wasted. And another alarming thing is here, the maximum meter per second, velocity, air velocity is very, very high because improper sizing. So this velocity should be minimum 15 meter per second. 15 meter per second means excellent, below 15. Above 30, 15 to 30 means somewhere average, but the maximum it goes 59.82. So next one. So this is the air leakage pattern, how much loss they have. Next. Next. Same thing, leakage. Next. Next. So the final topic is the energy audit, can be taken as a separate topic for the energy audit. So now I can complete my presentation, sir. I can finish. It's okay, sir. Hello?
Yes.
Hello?
Yeah, we can wind up.
Yeah, now we can wind up. We can do separate session maybe for the energy audits.
Yes.
Yes, sir. Sir, thank you very much, Sivakumar, sir. If there are any further questions, we can take the questions for Sivakumar, sir.
Okay, sir. So first of all, thanks for the opportunity for sharing the experience. Thank you.
Yes, sir. Yes, sir. It was a very practical presentation, sir. Lot of very relatable numbers and need of the hour, sir. Thank you very much.
Thank you.
Yes, sir. Sir, any questions to Shivakumar, sir, from the audience?
It's very nice, refreshing section. Very nice.
Sir, I have a question, Shivakumar, sir.
Yes, sir.
Sir, you were discussing about the furnace sintering.
Yes, sir.
In that, you had mentioned about kilowatt sintering.
Yes, sir.
But generally, if you see refractory manufacturers, they recommend sintering by the way of temperature. They use a thermocouple and then they go with the temperature.
Okay.
So, how do you look at that, sir?
Yes, sir. Yes, sir.
Shivakumar, sir?
Yes, sir. So
Sir,
regarding
yeah,
this sintering practices, no?
yeah.
Yeah, see, basically, I am also electrical. I am not a metallurgy person. Okay, I am electronics and communication person. So when we discussed with some experts, so they suggested this is the one of the old practices, and the
Yeah,
furnace
exactly.
is also more very old only, more than 20 years old only. So that in the existing practices and this one practices, no, we can change the practices. So for example, 125 kilowatt is given for 1 minute, 9 minutes the 0 kilowatt. That is a shock is given for sometimes, and again this one cold one is given. So
Exactly,
this
sir. That
way,
is why.
yeah,
Yeah.
gradually they rise. The next hour,
Yes.
2 minutes on, 8 minutes off. The 6 cycles was taken. So this
Yeah.
was happened. So the sintering cycle taken, so that the lining will be ensured. After that, not only sintering practices, because of this raw material charging sequence and patterns also, the entire thing, these two practices they adapted, so that they are able to take this specific energy consumption little bit less without investing any money.
Right, sir. So, no, my question was, see, generally what happens is refractory, they say it understands temperature and not power. So
Okay, okay.
that is why they say that you should go with thermocouple based sintering. Maybe if you are looking at maybe iron foundry, you can
Okay,
go
yes.
at 110 degrees per hour.
Okay.
And by doing that, you will be able to achieve better
Okay, you
sintering.
are speaking about the thermal angle. So every 1 hour, 110 degree to be gradually increasing.
Yeah. If you do that, we have seen some
Here they
places where.
taken only the GLD, sir, ground leakage detector current only now. In the existing system, they are not taking the GLD.
Ah,
So now they are taken note of the GLD value in terms of milliamps. It was noted, no. So that is also taken.
got it, sir. Okay.
Okay, sir.
Any
Okay.
any further questions, gentlemen? If there are no further questions, I think we will. Sorry?
Yeah, happy evening, sir. Very
Yes.
good presentation. Very elaborative, very informative presentation, sir. So regarding the kilowatt, this is Kumar from SAC Engine Component, Gumdipundi,
Yes, yes.
near Chennai.
Okay.
Kumar, sir. Yes.
Yes, sir. Yeah, very good presentation. So
Okay.
regarding the kilowatt, you said it is 500. Some foundries are achieving. So is there any benchmark foundry in India or from Coimbatore 500 kilowatt per metric ton?
No, sir, not that is a typical error. It's around 560, not a 500.
Got it. Okay, I thought people are achieving 500, so we can consider as a benchmark
Typical
foundry, so we can
typical
visit.
error. It is around 560 only. But basically, in
Okay.
Coimbatore also, some foundry units are getting nearly 600 below, even though the same raw material they are using, because of this best practices and the continuous operation. Most of the foundry, the
Okay.
medium, small industries, no, they are operating for only 12 hours. Every day they are doing the cold start, and also they hold the
Okay.
metal. The this one track line is not prepared for the pouring, so that these are the various other aspects to increase the energy consumption. So not only the furnace is not a main thing, the other areas, production planning and other coordination is also very important. So it all will leads. So some foundries are taken more than 750, or 800 units are there also achieved per ton of liquid metal. But practically, theoretically, they shown only 400. But practically, it can be done around 600 to 630.
Yeah,
Only the
okay,
big
okay.
foundries and
Yeah.
the corporates, they can able to achieve because of proper planning, and all those things are scheduled so that they can able to achieve this less kilowatt. But this
Okay.
awareness is not there for the medium and small industries, micro and small industries. This awareness is not there.
Yes, sir. Then regarding the heel metal, our people are telling if we keep some heel metal, the output is coming very fast per heat. The less with less time they are taking metal out. But
What is what is your capacity?
500 kilos.
500 kilos is the crucible melting capacity.
450 kilowatt.
450 kilowatt is the furnace heating capacity, correct? Okay, sir.
500 kg is yeah, furnace capacity. Kilowatt is 450 kilowatt.
450 kilowatt. How much heel metal you are maintaining, sir?
They keep around 56 kgs.
52?
60, 70 kgs. 50 to 75 kgs they keep.
Okay, sir. 50 to 75 kgs is not a matter, but some bigger foundries they are having, because of the mold and the track line is not ready, no? They are maintaining nearly 500 kgs heel metal. Out of this 1.5 tons, they poured only 900 kgs or 1000 kg. Remaining almost 500 to 600 kgs they maintain as a heel metal. But the 50 to 60 is okay. That is not an issue. But the few industries in Coimbatore itself, one of the foundry was using 1.5 tons and 2 tons capacity. Because of this mold is not ready and they are not able to pour the metal. So that's why they are maintaining the heel metal. Even some 3 or 4 furnaces are there. In that case, we suggested better you switch off one furnaces, use 3 furnaces. Better you take all the metal. So in your case, only 50, 60 kgs is not a matter, but in capacity, nearly 30% of the metal is maintained as the heel metal means it consumes more energy, lot of waste of power.
Yes, sir. Thank you, sir. Thank you so much. Very good presentation. Can you please share your card so that we can keep in touch?
Dinesh. Hello, Dinesh. Sir, you note down my number, sir. My number is, my name R.Sivakumar.
Yes, sir.
99652.
Yes, sir.
50504.
Thank you so much, sir.
Next, the same
I put it in the chat box.
Okay.
I put it in the chat box. Members can take the number, sir.
Okay, sir. I mentioned my mail ID also, sir. We are undertaking more energy audits in the sector. Nearly 50 to 60 found units are getting audited, and we are given more energy saving options. Actually, I have not covered the last chapter. We can do separate session for this energy auditing and what is the importance of energy auditing. Okay.
Yes, sir. Yes, sir. Yes, sir.
Right, sir.
If
You are
anybody
second
needs
in
the energy
Coimbatore.
auditing in the foundry, you can able to contact me and or send a request through this mail ID. So we can able to serve the industry, sir, your foundry units. Okay. My mail ID is siva.raja076@gmail.com. Not a mail, gmail.com. siva.raja076@gmail.com.
Right, sir. Sir, thank you very much, sir.
Thank you, sir. Thank you, sir.
Thank you.
Sir,
Gentlemen,
define
we have
IoT,
had-
sir. Sir, define IoT.
IoT is
sir,
Internet of Things.
Sir, sorry, sir, requesting members to please take questions by mail or this thing because it has gone more than 2 hours. Sorry. Sorry, sir.
Hello.
Yeah.
Hello.
Hello?
Sir, this is Venkatesh from Ashton.
Okay.
Sir, that is what I'm talking, sir. Sorry. We are making Foundrymen wait for more than 2 hours. So requesting members to please contact him over phone or by mail, sir, please.
Hello. Hello.
Hello?
சார் நாங்கள் ரொம்ப எதிர்பார்த்தது எனர்ஜி ஆடிட் டாபிக் தான் சார் ரொம்ப எதிர்பார்த்துட்டு இருந்தோம். பட் ஆஸ் சூன் அஸ் பாசிபிள் நீங்க இந்த ஷெட்யூல் பண்ணி கொஞ்சம் சீக்கிரமா இந்த இது சொல்லணும் சார், பிரசன்டேஷன் பண்ணணும் சார்.
கண்டிப்பாங்க சார், கண்டிப்பாங்க சார். சார் இது என்னோட நம்பருங்க சார். நான் இந்த இதை வந்து பிரசன்டேஷன் நான் வந்து இவங்களுக்கு அனுப்பிடுறேன். சதன் அந்த சென்னை சாப்டருக்கு. அவங்க மெம்பர் பார்ட்டிசிபென்ட்ஸ் எல்லாத்துக்குமே அந்த பிபிடி அனுப்பிச்சிருவாங்க. பிடிஎஃப்ல இருக்குது. ஆல்ரெடி ஐ ஷேர்டு. ஓகேங்களா? உங்களுக்கு
Okay,
எனர்ஜி
sir.
ரிகார்டிங் இது இருந்ததுன்னா நீங்க இந்த நம்பர் சேம் நம்பர் தான் வாட்ஸ்அப். இதுல நீங்க கான்டாக்ட் பண்ணலாம்,
Okay.
போன்ல நீங்க பேசலாம் சார்.
ஓகே சார். நான் எனக்கு அந்த எனர்ஜி ஆடிட் தான் இவனோட உட்காந்து வெயிட் பண்ணியிருந்தோம். பட் அது செஷன் வரலன்னும் போது கொஞ்சம் கஷ்டமா இருக்கு, வேற ஒன்றும் இல்லை.
ஓகேங்க சார். ஓகே, நீங்க போன்ல பேசுங்க சார், ஒன்றும் ப்ராப்ளம் இல்லைங்க சார்.
ஓகே சார்.
ஓகேங்க சார்.
Thank you, sir. Sir, now we'll proceed with the vote of thanks.
Yes,
So,
sir.
gentlemen, we have had a very interesting webinar today on the topic best operating practices for energy conservation. We are sure the contents of the presentation had a lot of takeaways for our audience. We would like to thank Dr.R.Sivakumar, Cluster Leader, GEF-UNIDO-BE, for taking his time off his busy schedule and making us rich with knowledge. Further, we would like to thank all the members who joined us for this talk. We are really happy that many of you joined us today. And thank you for acknowledging our WhatsApp and mail invitations and joining us on time. I'm sure you had a wonderful learning experience. We from Chennai chapter will have many more interesting programs and will be sharing the information to you soon. Requesting you all to join in our programs and make it a grand success. Thank you very much, gentlemen. Thank you.